In section 7.3, we're gonna learn how to prove that two triangles are similar. And they're giving us three properties, okay? The first property, it's angle, like the Star Wars. So angle, for you to use the angle similarity theorem, you have to have two angles congruent to two angles congruent from another triangle. Okay, so notice that these two are congruent to these two right here. Okay. The second one, side. And for this one, you're gonna have three sides proportional to three sides from another triangle. So when you get the sides and you get the ratio and you simplify the ratio, it's gotta have, it has to have the same ratio. It's gotta be the same. The third one, side angle side. And for side angle side, you're gonna have two sides proportional and one included angle, congruent. This is congruent, okay? So like in this case, tick mark, this is a similarity mark, and I put a similarity mark on the 18. So if you compare 15 to 18, that would be, by 3 is 5, so it's 5/6. And if you compare CA to DF, 10/12, when you reduce it, that would be, reduced by 2 would be 5/6. So the ratio is the same. Well, see, notice that I have a 57. It's an included angle, like this. So I can start by saying, well, let me compare this one with this one. If it doesn't work, I don't get the same thing, then I can do the other combination, this one with this one. Yes, please, thank you. So, and the included angle is congruent, okay? Now, in example number 1, so in problem number 1, it says, explain how you know the triangles are similar. And for that, we use one of the three properties to prove. And write a similarity statement. If they are congruent, then, similar, then we can write the statement. See, notice that here, I was looking for the missing angle. I was given two angles, but see, those two angles are not congruent. So I found the third angle by adding 49 plus 92. That's 141. How do I get the 39?
Subtracting from 180.
You subtract 141 from 180, and that gives you the 39. And the same thing happens with the other triangle. The sum of 92 and 39 is 131. Subtract from 180, and that's 49. What's the property that allows you to find that missing angle? The name of the property is sum angle theorem. Okay, the sum angle theorem says that the sum of the three angles equals to 180. So I'm using the sum angle theorem. So yes, they're similar by angle similarity. That squiggle line, it's a similarity theorem. So that means that's missing an M here, the theorem. Okay, so the triangle RQS, and see, I'm pointing here with an arrow. I'm coming this way, and then I'm coming this way. So from the 49 to the 92, and then from the 92 to the 39, 92 to the, so I need to guide myself in which direction I'm going to go so that I can write my statement. So it's RQS. It's similar to triangle UTV, and that would be the answer. Okay. Problem number 2. In number 2, we're given only sides. But see, these I marked them congruent because they're vertical angles. So I can mark those congruent because congruent angles, there are vertical angles, okay, are formed with intersecting lines. So these are vertical angles. So what I did is I compare HJ to LJ. And that's usually the case, okay? They go kind of like a cross. This would be similar to this. And then this would be similar to this. So I wrote HJ over LJ, which is 18/27. Then I reduced by what number? I reduce not by 3, by the biggest number that goes into 18 and 27 is 9. I reduce by 9 is 2, by 9 is 3. Then I set up the other ratio, which is GJ. See, I started with the left triangle, so I have to start with the left triangle and my other ratio. Very important that you do that. Is to KJ. So the numbers are 16 and 24, and here I reduce by what? 8 is 2, 8 is 3. Since the sides are proportional and the included angles are congruent, then yes, these triangles are similar by the side angle side similarity theorem. It only matters from where you're coming. Like if you're using J, yes, you can do it HJ or JH, that would be okay. Okay.
Like you're saying, if you can put 18 over 16.
18 over 16. If you want to do that, then you have to put HJ over GJ. Is that what you want to do? If that's what you want to do, you can go ahead and do that. Then you have to start over here. KV is to KJ is to JL. Now, if you do that, that's going to be 18 over 16.
Where do you get the same answer?
The ratio would be different, but it would be the same from left to right.
So it wouldn't matter.
How you set it up. Because at the end, see, if I put 18 over 16, I can reduce it by 3, right? No, by 2. By 2 is 9. By 2 is 8. So that ratio would be 9 over 8. Now let's do this over here. I'm coming from the green one to the yellow one. So I have to come from the green one to the yellow one. So 27 over 24, let's simplify it by 3, right? By 3 is 9, by 3 is 8. So the ratio is the same. 9 over 8, 9 over 8. You get, the ratio would be the same, not the same as this one. So the ratios would be the same if you set them up like that. Yes. So
It doesn't matter where you set it up.
how do you set it up? No, as long as you're careful on, how you set it up, like, same one side of this triangle over the other side, and then you check one side of the other triangle over the other side. And then that should give you the same ratio. If it does, then you can say sides are proportional and the angles are congruent, so it's side angle side. Okay? Good questions. Number 3, let's move on to number 3. Number 3, it says verify that those two triangles are similar. So what I'm doing here, I'm comparing AC to MP. That's 12 over 15. Reduced by what number? I can simplify it. By 3 was 4, by 3 is 5. Good. And then I'm comparing AB. That would be to MN. That's 12 over 15. And the same thing here, by 3 is 4 over 5. And then the base, which is CB, is to PN. It's supposed to be PN here, right? This is PN. And that equals to 8 over 10. Then reduced by 8, by 2 is 4, by 2 is 5. So it's 4/5. So notice that all the sides came up with the same ratio. Therefore, these triangles, ABC and M and P, are similar by side, similar to there. Okay. Any questions on these 3 examples?
Ma'am,
Ma-
for the top one,
Uh-huh.
for number 2, you got the angle right?